Okay, so now we'll go to the next step. That is step number 8. Okay, so we can make a note of this one. You can write it, step number 8. So in the step number 8, we will find the breakaway point. Okay, so you can write that to find breakaway point. So this is the step number 8. In order to find the breakaway point, what you will do is you have to take the system characteristic equation first. Okay, so write down system characteristic equation is given by 1 plus g of s into h of s is equal to 0. So we need to substitute the value of 1 plus g of s into h of s. So g of s into h of s, they have given the value, that is k into s plus 6 divided by s into s plus 1 into s plus 2. So that is equal to 0. Okay. So now if you do the cross multiplication and if you simplify the equation, so you will get like s into s plus 1 into s plus 2 into plus k into s plus 6, that will be equal to 0. So this is the equation for characteristic equation. So now from this particular equation we can find out the value of k. So what is the value of k? So k will be equal to, if we shift the terms to that side, it will be minus of s into s plus 1 into s plus 2, so whole divided by s plus 6, whole divided by s plus 6. So this is the value of k. So you can just remove the negative sign. So it will be like a minus of s cube plus 3s square plus 2s divided by s plus 6. So this is the value you are going to get for k. So please all of you check it out whether you will get the same answer or any other answer. I hope that all of you will get the same answer. So now after this one we can go for the next thing, that is at breakaway point. At breakaway point, so dk divided by ds is equal to 0. dk divided by ds equal to 0. So this is the condition what we have already learned. So now we need to differentiate the k with respect to s. So now in this particular numerical, so what exactly will happen is it is in the form of a divided by b. So in the differentiation, you know that how to differentiate the a divided by b concept. So you will get after once you differentiate the things, okay, so you will get minus of s plus 6 into 3s square plus 6s plus 2 minus s cube plus 3s square plus 2s whole divided by s plus 6 whole square. So that is equal to 0. Okay, this is what exactly you are going to get. So after you getting this one, so if you further simplify, you will get like, so 2s cube plus 21s square plus 36s plus 12 equal to 0. Clear? So this is the equation what you are going to get. So I know that it will take some time for you to solve it. So you can just make a note of this one and you can try it at your home. So whether we get the same answer or not, you can go into check it out. So this is the equation. So now if you find out the roots of the equation. So if you find out roots of above equation, so what is the roots of above equation is saying? So s will be equal to what? So one root will be minus 0.4429 you will get, and the second root is what, s equal to minus 8.455 you will get, and s equal to minus 1.602 you will get. So these three roots you are going to get. So because this is the polynomial of degree 2. So once you get this particular things, okay, so you need to substitute this particular value to the equation k, and you have to see that the k value is positive or not. Okay, so when I substitute this particular value, I got k equal to 0.069, and when I substitute s equal to minus 8.455, I got minus 165.73. And the third thing is what, when I substitute this particular value, I got k equal to minus 0.0872. So three values I got. So out of this particular three values, I can say that only one value is positive. So there is a condition, k must be greater than or equal to 0. For that, k equal to 0.69 is holding good. So when the k equal to 0.069 is the it is greater than 0. For that, s equal to what the value we got? We got s equal to minus 0.4429. So this is the value we got. Clear? So this particular value we got. So that particular value is called as what? Breakaway point. Okay. So therefore the breakaway point is, we can say that therefore breakaway point is equal to minus 0.4429. So that is what exactly you can able to write it down. So once you're done with this one, so we'll go for the next step, that is step number 9. Okay, so step number 9 we will go. So what is the step number 9 is saying? It is saying that the root locus is symmetrical. Root locus is symmetrical with respect to real axis. So this is a very important step here. Okay, so root locus is symmetrical with respect to the real axis. So this step we need to observe in the root locus. We are not going to solve anything. So then the final step for this particular numerical, we have to find out the intersection point. So write down to find intersection points. To find intersection points. So intersection points on what? J omega axis. Okay, so intersection point on the j omega axis and range of k for closed loop stability. To find intersection points on j omega axis and the range of k for closed loop stability, we are going to find out. So in order to find that particular thing also, so we need to have the characteristic equation. Okay, so I can say that system characteristic equation. So that is 1 plus g of s into h of s is equal to 0. So here I can say that s cube plus 3s square plus k plus 2 into s plus 6k equal to 0 is the equation what we got. So I told you that we can do this particular process of finding the intersection points on j omega axis as well as the range of k. So we need to put s equal to j omega. Okay, so now we will put the s equal to j omega. So that means what, j omega whole cube plus 3 into j omega square plus k plus 2 into j omega plus 6k equal to 0. So in that case, what exactly happens is j square is minus 1. Minus 1 into j is minus j. So I can say that j omega whole cube equal to minus j omega whole cube. Okay, minus 3 omega square. J square is what? Minus 1. So after that plus k plus 2 into j omega plus 6k is equal to 0. So this is the equation what we got. So once we substitute the values. So now in that case, what exactly we do is, so we need to separate the real terms and imaginary terms. So once we are separating the real terms and imaginary terms, so we get like 6k minus 3 omega square plus j into k plus 2 into omega minus omega cube equal to 0. So it is in the form of a plus j b equal to 0. So in order to get RHS equal to 0, LHS means the both real term should be equal to 0 and imaginary term should also be equal to 0. So in that case, what exactly we get is, so we can get like so 6k minus 3 omega square is equal to 0. So in that case, 6k equal to what? 3 omega square. Okay. So here omega square will be equal to what? 2k. So 3 ones are 3 twos are. So omega square will be equal to what? 2k. That is what exactly we get. So now the next equation, another equation is what? K plus 2 into omega minus omega cube, okay, equal to 0. So take omega outside. So you will be left with k plus 2 minus omega equal to 0. So you know that frequency cannot be equal to 0. That is why k plus 2, okay, minus omega square should be equal to 0. So k plus 2 should be equal to omega square. So this is what exactly we get. So and after we getting this particular k plus 2 equal to omega square, okay. So we know that in the previous step we got that omega square equal to 2k, right? So here omega square equal to 2k, that we can able to replace here. So therefore k plus 2 equal to 2k. Okay, so 2 equal to 2k minus k. So here k will be equal to 2. So therefore we get the k equal to value 2. This is what exactly the value we get for k equal to 2. Clear? So now once we get the k equal to 2, that means what? The closed loop stability range is what? 0 less than k less than 2. So this is what exactly the value we get. Okay. So omega will be equal to what? Omega square equal to 2k. So therefore omega will be equal to plus or minus square root of 2k. So omega will be plus or minus square root of 4. So omega equal to plus or minus 2. Okay, so this is the value of omega. Omega equal to plus or minus 2, and k is also equal to the maximum value 2. So these are the two values what we get, okay, from this particular numerical. Do you have any doubt in this particular numerical, any one of you? So once we get this particular thing, so we can go for the plotting of root locus. So let us write down. Let us plot. Let us plot root locus. Okay. So when you are plotting the root locus, we can make it like. So we'll draw the S-plane. Okay. So when you are writing the S-plane, so this is the S-plane we say. So in the S-plane, this is the x-axis is sigma and the y-axis is what? J omega. So now what is the first step? First step is what? We have to mark the poles. So when you are marking the poles, where the poles are there? Where the poles are there? So poles are in s equal to 0 and s equal to -1 and s equal to -2. So you can see here, I can mark it s equal to 0 and here s equal to -1 and here s equal to -2. And after that there is a 0. Okay. So that is equal to -6. It is. So anyhow, yeah, go to just mark that is equal to -6 is 0. So now after we marking this one, okay, we need to mark the centroid. So where is the centroid point? Centroid point is 1.5, that is plus positive 1.5. So positive 1.5 means what? Somewhere here, if it is 1 and here it may be 1.5. So sigma A I will represent here, that is centroid is 1.5. So once I make the centroid equal to 1.5, so we need to take the angle. So when you're taking the angle, there are two asymptotes here. So the first asymptote is at the 90 degree. That means what? Exactly at the perpendicular. Okay. So exactly the perpendicular value. That is AS1 as I say. So I can say that this angle is 90 degrees. The second angle is asymptote 2. That is asymptote 2. That is at the angle 270 degree. 270 degree means at exactly the minus 90 degree. It is opposite. Okay. So these two are asymptotes at an angle 90 degree as well as at an angle 270 degrees. So now breakaway point we need to consider. Where is exactly the breakaway point will come? It is in the minus 0.4429. Okay, so here I can say that breakaway point is minus 0.4429. So here if it is 0.5 and it is somewhere here, okay, somewhere here it is BAP, that is breakaway point. So minus 0.4429. So once this particular breakaway point we are considered, so we need to mark the point of intersection. So point of intersection means what? Omega value. So if omega equal to plus minus 2, j omega equal to, okay, so plus or minus j2. So here plus j2, if it is 1 and if it is 2, here 2 may be coming here. So that is positive j2 and here it is negative j2. We are going to make it. It is point of intersection. So once we get the point of intersection, I told you that from the breakaway point to the point of intersection, we need to draw the line, curved line. Okay. So here also I need to make it curved line here. So like you can able to write it properly. So you can make it very clearly, the line. So like this it will come. So once it comes, no, so you can say that you can continue this particular angle of intersection, but it will go in the 90-degree exactly, that is in the straight line. So like that it is going to pass because it is not going to touch anywhere. So at this particular point it will start. So once it reaches this cutoff point, so here k equal to 2. So here k equal to 2 only it will come. Okay. So like this we need to draw it. So and we need to say that one sentence that for a closed loop stability, k value should be between 0 to 2. Okay. So this is what exactly the concept. So do you have any doubt in this particular numerical? Anyone of you? Since we have not got any complex poles and complex zeros, so we are not obtaining any angle of arrival and angle of departure. That type of numerical also we will discuss in our further classes. So as of now, is it clear to you, all of you?
Yes, sir.
Okay. So now we can go for the next numerical, I think so. So take this particular numerical, all of you. A negative feedback control system, a negative feedback control system is characterized by g of s into h of s is equal to k divided by so s into s plus 1 into s plus 2 into s plus 3. Sketch the root locus plot for the k ranging from 0 to infinity. Ranging from 0 to infinity. So here there is a sentence that is sketch the root locus plot for the k value ranging from 0 to infinity. It indicates that the branch of the root locus starts from the 0 and it should end at infinity. That is what exactly the meaning. So in this particular numerical there are 4 poles are there. That is s equal to 0, s equal to -1, -2, -3. So these 4 poles are there. So these 4 poles are not having the zeros, so that means what they will be ending at infinity. That is all. Okay. So like the previous two numericals, so this numerical also you can able to solve it very easily. Okay. So what is the step number 1? Will step number 2 like that? We'll go and we'll keep on solving this one. Very interesting numerical this one. Okay. So now write down the solution. So how much it is possible? So that much of steps we'll see for the next 10 minutes, and after that okay, so rest of the things you can do it at your home, or else we'll see in the next class. Solution, the step number 1. What is the step number 1 is saying? plot the poles and zeros of g of s into h of s on the s plane. Plot the poles and zeros of g of s into h of s on the s plane. Okay, that is the first thing. So now if I just plot it, it will be coming like this. So it will be sigma and it will be j omega, and this is called as what s plane we say. And here it is origin. So s equal to, what are the values? S equal to 0, minus 1, minus 2, minus 3, because in this particular equation if you take the roots, so it will implies that s equal to what? 0, comma, minus 1, comma, minus 2, comma, minus 3. So here s equal to 0, here s equal to minus 1, here s equal to minus 2, and here s equal to minus 3. So this is the plotting of poles and zeros. Since there is no zeros, we need not to plot anything. So once you plot this particular thing, so you can go for the next step. That is step number 2. K equal to 0. So the points are 0, minus 1, minus 2, minus 3. So when k equal to infinity, so the points are, so here what you call for that, there are no zeros. So I can say that infinity, 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 and infinity. So for every pole there should be a 0. If zeros are not present, okay, so we can consider at the infinity. So if in the reverse case it happens, like there are many number of zeros and there are less number of poles, so we can consider them as at zeros. That means what? At p is equal to 0 only we can consider. At the origin there are some poles like that we can consider. Okay, so is equal to infinity, 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 and infinity. So step number 3, a branch of root locus, a branch of root locus, starts on a pole, that is k equal to 0, and ends on a 0, that is k equal to infinity. A branch of root locus starts on a pole, that is k equal to 0, and ends on a 0, that is k equal to infinity. So this is the next step. So next step, step number 4, if you are seeing, okay, so step number 4, that is the number of branches. Number of branches of root locus, number of branches of root locus, that is equal to P or Z. So here whichever is greater. So P or Z, whichever is greater. So which is greater? So we know that P equal to 4 and Z equal to 0. So P greater than Z. Therefore, the branches equal to 4. Therefore, number of branches equal to 4. So next is what? Step number 5. So when talking about the step number 5, a point on the real axis, a point on the real axis lies on the root locus, lies on root locus if number of singularities, if number of singularities is odd number, is odd on right of the point, on right of the point. So after that we can say that the step number 6. So step number 6 indicates the number of asymptotes. Okay, so in that first one is what number of asymptotes. So when talking about number of asymptotes, so number of asymptotes. So when you're talking about number of asymptotes will be equal to P minus Z. So P minus Z is equal to, okay, P minus Z is equal to what? So it is 4 minus 0, that is equal to 4. Okay, so next in what? Second one. So the second one, it is centroid. Okay, centroid of the asymptotes. Centroid of the asymptote. So when talking about centroid of the asymptote, there is a formula to find out. What is that particular formula? Sigma A is equal to summation of finite poles minus summation of finite zeros divided by P minus Z. So when talking about summation of finite poles, it is 0 minus 1 minus 2 minus 3, and zeros are 0, nothing else is there. So 4 minus 0. So you will get the sigma A value as minus 1.5. Please check it out. Okay, so here you will get the value sigma A equal to minus 1.5. So once you get this particular thing, so the next thing is what? The angle made by asymptotes. Okay, the angle made by asymptote. So with respect to real axis is given by phi A is equal to 2q plus 1 into 180 degrees divided by P minus Z. So Q will be equal to 0, 1, 2, 3, because since the 4 asymptotes are there, Q value ranges from 0 to 3, that is 0, 1, 2, 3. Okay. So once it is done, like 0, 1, 2, 3. Okay, so we need to find out the values. So once we are finding the values of phi, so we can get like hence we get phi A. So that is equal to 45 degrees. You just calculate 45 degrees when Q equal to 0. Similarly, phi A will be equal to 135 degrees when Q equal to 1. Similarly, phi A will be equal to 225 degrees when Q equal to 2. Similarly, phi A will be equal to 315 degrees when Q equal to 3. So this is the value what we get. For example, if you take QA equal to, so 2 into 3, okay, minus plus 1. 2 into 3 plus 1 divided by 4 minus 0. So that will be multiplied with 180 degrees. Okay, so 180 degrees. So equal to what? 2 into 3, 6, 6 plus 1 is 7. 7 into 180 divided by 4. Okay, so it will be yielding to 315 degrees. So you can just calculate. Clear? So like this, for every step you need to calculate, it is phi a equal to what? Phi a when q equal to what? Q equal to 0 equal to what? Q equal to 1, then equal to what? Then q equal to 2, phi a equal to what? Q equal to 3, phi a equal to what? So like this, if you calculate, you will get the 4 answers. Is it clear to you?